Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Hey everyone, welcome to today's explainer. You know, software bugs cost the global economy literally trillions of dollars every single year. It's wild. So today, we're unpacking a really fascinating concept in software quality assurance to combat that. We're going to explore the core mystery of verifying super complex systems without ever laying eyes on a single line of the underlying code. Sounds kind of like magic, right? Like, how can you possibly guarantee a system is working flawlessly if you can't actually see how it's built on the inside? Well, stick with me, because by the end of our time together, you're going to understand exactly how the pros pull this off and how they use structured visuals to guarantee flawless performance. To really grasp this, I want you to picture standing right in front of a literal mystery box. You can't open it, there's no way to see the gears turning inside, the wires crossing, or the logic circuits firing. All you've got is a slot to put something in and a chute where something pops out. If you put a coin in and a candy bar comes out, boom. You know the box works for that specific transaction. It doesn't really matter what the invisible machinery inside is doing. And in the world of software development, this isn't just a fun metaphor. It's a rigorous, highly respected methodology. Okay, let's dive right into this and unlock the black box. Let's look at the actual philosophy behind this testing method. Let's formally define what this mystery box approach actually is. Black box testing involves testing against a system where the code and the internal paths are, well, completely invisible to the person doing the testing. To the tester, the internal mechanics are totally unknown, and that turns the whole validation process into a pure input-output exercise. You're not in there debugging a developer's specific coding choices. Instead, you're strictly measuring cause and effect. You trigger an action, and you measure the reaction. Simple as that. Let's break down the key characteristics here, because this is where the power of this approach really shines. Number one, the tester has absolutely no knowledge of the internal code. This creates that purely input-output driven approach we just talked about. But why does that actually matter? Well, it forces the testing to be done entirely from the user's perspective, and that is absolutely crucial. The big advantage here is that it prioritizes actual functionality and usability over technical implementation. Let's be real, a user doesn't care if the code is this elegant masterpiece or if it's held together by digital duct tape. They just want the app to work. And what's really beautiful is that this methodology applies at literally every single level of a system's lifecycle, from basic unit testing all the way up to integration, final acceptance, and even critical security testing. Now, let's shift gears and talk about how we handle things when they get complicated, using something called the decision table. Because what happens when that mystery box gets highly complicated? Like when you aren't just putting in a single coin, but rather a whole combination of coins, tokens, and buttons, and all of them change what comes out of the chute. So the crucial point here is that when multiple inputs can have different values and result in entirely different outputs, you absolutely need a structured framework. You can't just randomly guess at combinations and hope you catch every possible error. Relying on guesswork for complex software is just a recipe for disaster, especially when different combinations of inputs fundamentally change how the system behaves. We need a reliable way to tame all that chaos. And that brings us right to decision table testing. As defined here, this is a systematic black box testing technique specifically designed for dealing with complex systems. Basically, it takes all of those messy overlapping variables and represents the inputs and outputs in a highly structured tabular form. Think of it as a tool that genuinely tames the chaos. It's like solving a giant puzzle in advance. By mapping out every single possible scenario in a clean, visual grid, QA teams can make absolutely sure that nothing gets missed. Every condition is accounted for, and every expected outcome is documented right there before the testing even begins. All right, let's get into the real-world application of this. Let's see how this works for testing a bank loan. Let's move from these abstract concepts to a real-world, high-stakes scenario, banking software. Imagine a bank is offering this highly desirable special loan, but they have very strict criteria coded into their software. Notice the two mandatory puzzle pieces for approval here. First, the applicant has to be a new customer. Second, they have to have a credit score strictly greater than 750. These are two hard mathematical rules. It's an and condition, right? Meaning both pieces of input must align perfectly for that approval output to trigger. Now, what's really interesting here is how this table completely demystifies the bank's hidden software logic. We've mapped out the 4 possible combinations of our 2 inputs. Take a look at rule 1. Is it a new customer? Yes. Is the credit score over 750? Yes. The outcome? Boom, loan approved. But then look at rules 2, 3, and 4. You can visually trace how changing literally just one of those inputs to no immediately results in a rejected outcome. The tester doesn't need to read a single line of the banking code. They just run these 4 specific test cases. If, say, Rule 2 somehow results in an approval, well, the tester instantly knows the invisible code is broken. Let's keep rolling with another example. Let's look at insurance premium logic and how we handle more nuanced variables. We're transitioning to our second practical example to see how this framework handles a slightly different set of variables. This time, we're looking at something a bit more nuanced than just a simple yes or no approval. In this health insurance scenario, the company's software calculates premium costs based on a combo of lifestyle and demographic inputs. Specifically, the system looks at age, so whether the applicant is under 40 or over 40, and it weighs that against smoking status, whether they're a smoker or a non-smoker. These 2 critical lifestyle inputs are going to directly determine a variable financial output. They dictate exactly which premium tier the customer gets assigned to. And this brilliantly illustrates exactly how a decision table organizes varied outcomes. Let's just read through the grid together real quick. Under Rule 1, if the applicant is older, so over 40, and a non-smoker, the outcome is Premium Tier 2, which is a medium premium. Interestingly, though, Rule 2 shows that if they're older but they do smoke, the outcome actually stays at a medium premium. But look down at the younger applicants. Rule 3 shows that being under 40 and a non-smoker gets you the absolute best result, Tier 3, the low premium. However, and this is a big however, Rule 4 reveals the steepest penalty. If you're under 40 and you do smoke, the software outputs Tier 1, the high premium. By just following this table, a tester can flawlessly verify that the low, medium, and high premiums are triggering perfectly without ever touching the source code. It's super effective. So, bringing this all together, let's move to our final takeaways and see how this builds into immense practical power for any software environment. First up, it proves that invisible code works perfectly just by verifying the outputs. Second, it systematically handles complex input combinations so that absolutely no edge case slips through the cracks. And honestly, most importantly, it secures high-stakes logic, stuff like financial loans and healthcare insurance, entirely from the user's perspective. It guarantees the system behaves exactly, and I mean exactly, as the customer expects it to. Which brings us to a final, kind of provocative thought I want to leave you with today. Think about it. If we can map every possible input and guarantee every correct output using a decision table, does the underlying code even really matter? If the user's experience is flawless and perfectly predictable, isn't that the ultimate definition of software success? It really challenges us to think about how we value all that hidden engineering versus the tangible, real-world user experience. Thank you so much for joining me for this explainer, and hey, keep questioning what's inside the box.